So we're going to work with inequalities. We're going to try to figure out when this function is less than the value of 0. So we have some cubic function. It probably does something like this, or it kind of does the complete opposite like this. We just don't know what exactly it's doing right now. Okay. Because this is positive, we have a pretty good idea that it's going to be a function like this, and we just got to figure out what values these x values are, when it's going to be a positive function or a negative function. And we can use some inferencing because we know this is a positive value to figure it out. What's key here, though, is when that function was crossing these coordinates. So we need to figure out when it's crossing these specific coordinates, which are the x-intercepts. So the very first thing you did was you decided to factor. So you tested a bunch of values, and you discovered that that one of the x-intercepts, okay, is when x is equal to 1, correct? Mm-hmm. So you quickly did some synthetic division. We took that one value, and we're going to add. We'll take the coefficients here. So we have 1, -2, -5, and 6. We bring the 1 down. 1 times 1 is 1. We add these together. We get -1. 1 times -1 is -1. -5 plus -1 is -6. 1 times -6 is -6. And we get a remainder 0. So when x is equal to 1, I need that to become a binomial. So I'm going to move the 1 to the other side. I get x -1 is equal to 0. Great. So that's essentially what I divided by when I go to build this equation. So I'm still less than 0. One of my factors is x minus 1, and we know that that equals 1. We created that. And our new equation here is 1x squared minus x minus 6. And then we can factor that part of this, right? We factor it by doing a product sum, and it looks like x minus 3, x plus 2. Is that right? As the other two factors you got? Great.
Yeah. Oh, minus 2 plus 2?
Yeah, I got minus 3. Yes, minus 3 plus 2 are the factors when I go through this. Reason being is because when I do product sum, I need two numbers that are going to multiply to -6. Is that what your mistake was?
Yeah, because I thought it, for some reason I wrote it as a positive. Like, I thought the sum had to be a positive. And
so because they both had to add up, to -1, that means the -3 has to be the value.
That's why my numbers are so reversed.
Okay. So let's continue with it, though. Let's see if we can kind of figure this out.
Just fix it.
So you can build a number line to solve something like this. There is actually a faster way of inferencing this information, but we're going to build a number line just to be safe here. So our x-intercepts are x at 1, x at 3, and x at -2. So we have a value at -2 when we cross the x-intercept, so assume this is x.
Do you have a big razor?
Yeah, there should be a couple there. We have a value at +1. So let's kind of do this. There's our y-intercept. We have a value at +1, and we have a value at +3. So 1 and 3. We want to know when the function is less than 0. So in other words, we want to know when it's below the x-axis. Okay? And we can do a bunch of testing with these values on our number line. I'm going to build another number line here. But I'm going to show you a really quick way to get this information without actually having to test these ideas. Okay? So we have our number line, and you would historically kind of do this. Choose a value less than less than -2 to test. You'd use a value between -2 and 0, so -2 and 1. You'd use a value between 1 and 3, so something like 2, and you'd use a value greater than 3, maybe something like 4. And then you would test all these and figure out where they're positive and negative, and it would give you these ideas. But if you look at this function, because this coefficient is positive, the very first one, and it's a cubic function, we know that cubic functions rise like this. Mm-hmm. Okay? So since we already know what the x-intercepts are, we know we're coming from a negative value, and we know that none of these are squared. Have you guys talked about when brackets are squared? Okay.
Well, not yet.
Because none of these are squared, so because they're the power of 1, what that means is they're going to cross through the x-intercepts. There's not going to be any turning at them or any like funny little things happening. So because they're the power of 1, what we can say is, we know they're going to cross through. We know this function is going to start down here. It's going to cross through at -2, do something, cross back down at 1, and cross back up at 3, because it's a positive function. Had it been a negative function, it would do the opposite. It'd be coming down, cross up, and cross down. The reason we can make these assumptions is because these are all to the power of 1. If they weren't to the power of 1, then there's a little bit of a different thing. But because they are, and this is positive, I can already tell you when the function is going to be less than 0. I know that anything to the left of -2 and anything between these two values will be less than 0 without having to do any of my number line testing.
Yeah.
Okay?